Right too. Alright, so partitioning and line segment notes. To partition, a line segment means to divide the line segment into a given ratio. The two numbers in the ratio must add together to equal the total number of pieces. So, all right, now it's about you splitting the line into pieces. Only what you've done so far with that is being able to do midpoint. But midpoint was just you cutting the line in half directly. So you split it down the middle and you got half and half. That's easy because you can just use the midpoint formula. Partitioning is a little bit different. Partition, you split it into pieces based on what ratio they give you, or they tell you. So before we get on the graph, let's just work on it just as a simple segment on paper. It says label point P that partitions a line segment A to B into a ratio of 3 to 2. So you split an A to B into a ratio of 3 to 2. It's pretty easy to do. Count over 3. It's my first split, 3. And then my second split is here, 2. So my partition point would be right here in the middle at 3 to 2. The next one, it says label the point P that partitions line segment AB into a ratio 1 to 4. Oh, you know what? Before I go to that, I know what I wanted to mention on here. So we split this 3 to 2. How many total pieces do you have, man? Yeah. If you want to figure that out, you would add your ratio together. 3 to 2 is 5. So you have 5 parts total. 1, 2, 3, 4, 5. The next one we split in 1 to 4. Partition point would be here. Same thing with this one. 1 plus 4 will give me 5 pieces in total. Last one, A to B, 2 to 3. Partition point is here. 2 plus 3 equals 5 parts in total, or 5 segments. So that's easy. I mean, it won't be that easy on the graph, but essentially right there. Here's your idea how you split the line with a ratio. Down here it says determine the ratio of the directed line segment AB when partitioned by point P. So they give you the line segment already partitioned. They want to know what the ratio would be. Missing, what's the first ratio? Armando, go ahead. No, like the full ratio, bro. 1 to 2. Thank you. Let's move on there. 1. Second one. Two to 3. Chris. Oh, say it again. I want to count again. Don't laugh. What you counting? Count your segments, man. Don't count dots. Count the segments. I think that's a good thing. Some of y'all be counting points. That's where you mess up at. You should be counting the segments. 5 to 1. Now, that's okay. That's a good teaching moment. I know some of y'all gonna count dots. That's where you're gonna mess up at. Count the segments that are created. Alright. So that's just how to split lines or whatever. Doing it on a coordinate plane, we got some steps we want you to follow. And I was telling the kids in the other class, I follow these steps, and I want you to too. Don't try to shortcut it. You try to shortcut it, that's when you're gonna take the L, because you're gonna think you faster than me. Now, certain ones of these, when you're doing partitioning, you may be able to shortcut and do without steps, but I don't want you to do that because I want you to get in the habit of doing the steps. Because some of them you will have to use the steps on, especially the decimal ones. We started out with whole numbers to build your confidence, but you know we're going to end up doing decimals because whole numbers are too easy. Alright. Step 1, determine the total number of parts the line is divided into. To determine the total number of parts, all you're doing is what we did up here. Figuring out what the ratio is and adding those two pieces together. That'll tell you the total number. So, like I said, 3 to 2, so I know it's 5. 1 to 4, I know it's 5. If it was 2 to 6, how many parts would you have? Good. Reese, if it was 3 to 5, how many parts would you have? Huh? What am I talking about? Faith, it was 3 to 5, how many parts would you have? Oh boy. Y'all ain't paying attention. Earl, go ahead. Thank you. Boy, I swear. I know you ain't paying attention. Yeah. So let me try you again. Reese, if it was 4 to 5, how many would you have? Alright. So first thing is determine the total number of parts that you got to divide into. Second thing is determine the length of the horizontal and vertical distance from endpoint to endpoint. Maybe make a note on this because that may sound crazy to you, but we've been doing this since the beginning of the year. This is where you're gonna make, can't spell make right, a right triangle. You're going to make a right triangle so you can get your horizontal and vertical distance. We've been doing that all year, so there should be no confusion on that. That's step 2. Step 3, we're going to divide each length that we get, the horizontal and vertical length, by the total number of parts found in step 1. Step 4, we're going to count from either endpoint the number of parts used to form the ratio. And on step 4, they say either endpoint, but they're going to specify. I don't even want to use the word neither. It will be a specific endpoint that we count from, depending on how they name the figure. On all these ones on the front, they call it A to B, but they could name the line BA. If they call the line BA, we're going the opposite direction. You'll see on the back what I'm talking about. You need to pay attention to that, though. Go to the back. Let's do it. Number 1. Says given points A at 3, 4, B at 6, 10, find the coordinates of point P on the directed line segment AB. That partitions AB into a ratio 2 to 1. First thing we're going to do is step 1. Step 1 said to figure out how many segments we have. Chris, on this one, how many segments will we have? It's a confusing question. Huh? On this one, how many segments will we have? Don't answer for Chris. Let him. How you get that? Adding what? Okay, just making sure. So yeah, 3 segments all together. Then from there, the next thing was to draw a triangle. We need to graph our points first, though. Should have did that probably first. Graph our points, and then we're gonna find our horizontal and vertical distance. So A is at 3, 4. B B is at 610. From there, so the partition says it's happening from A to B. So we're going from A to B to our partition. So from A to B, I want to draw a horizontal and then a vertical line getting me from A to B. So from A to B, I'm going horizontal first. Then vertical. Just making my triangle. We've done this too many times before, so nobody should be confused. Not necessarily. Could be considered that, because it will be kind of sloped that you'll be counting. Alright. Then from there, I want to know my horizontal distance from A to B. Now, on this, our horizontal can be positive or negative depending on which way we're going. But from A to B, we're going to the right. That's positive, right? Alright, so that's 3. And then from A to B, we're going up. So that's positive as well. Up how many? 6. So these are my movements horizontal and vertically. So up top here, I'm going to write that. And I'm not going to write out the whole word horizontal. I'm going to just use H. Understand that H stands for horizontal. My horizontal movement was 3. My vertical movement was 6. The next line or the next step tells you to divide each length, which we just got, those 2 lengths, by the total number of parts found in step 1. Chris told us we had 3 segments or 3 parts. So we're going to divide by 3. Both of these lengths, the horizontal and vertical, gets divided by the 3 from the top. Three divided by 3 leaves you with 1. 6 divided by 3 leaves you with 2. What this is telling you how to partition your line. It's telling you how many steps to take each way to do your partitions. So once I get those numbers, what it's telling me is horizontally, I'm moving 1. Vertically, I'm moving 2 every time I partition. My partition is split 2 to 1. So to get my point, I got to do it twice. So from A, I'm going to the right 1 horizontally, then I'm going up 1, 2. Just following what I just calculated. And then I got to do it again. Over 1, up 1, 2. Doing it twice to get me my 2 to 1 split. 2 is right there, the 1 will be over there. So it's my partition point right here at P. And then I just need to read that point off of there. Where's that actual point at? Where's point P? Yeah, 5, 8. This is how you partition. Some of them will be simple like this, but not most of them. So partition points 5 to 8. 5, 8. Questions on that first one? If you got one, ask it. Think I went slow enough? What's up? 1 and 2. Yeah. So we're going from A to B. Understand the partitions happen from A to B. So just telling me how far to walk. Over 1 to the right horizontally, up 2 vertically. Because I'm going from A to B, so it has to be that kind of walk. You feel me? So over 1, up 2, over 1, up 2, over 1, up 2 would have landed me on my other point. So this is my splits. And now I split the line 2 to 1 like they asked me to. Alright. Number 2. This one, let's graph the points first. Let's do it the right way. Graph the points first. So A is at -3, 2. B is at 6, 1. -3, -2, excuse me, I'm saying that right. B is at 6, 1. And once you graph that, it reads, it says find the coordinates of point P on the directed line segment BA. That partition is BA in the ratio 1 to 2. Anybody notice anything different about this one? I'm asking. Yeah, the ratio is different. Anything else? Huh? There you go. Dior said it. It's asking me to go from B to A. It's not telling me to partition from A to B on this, so you need to pay attention. If you go the wrong way, you're going to give me the wrong point. This one is asking me to go from B to A and do my partition. It's telling me my ratio is 1 to 2, but it's telling me to go from B to A. Alright. So if that's the case, first thing, how many parts do we have, or segments? 3. I'm still recording, y'all. Be easy. Alright, so from there, I got my number of segments. Then from there, I want to make my triangle. But this triangle, I'm making it from B to A. And I'm going horizontal first. So what I want to do, I want to do my horizontal going back from B to A. Here. B back to A. And then down to my vertical. That's what I'm about to tell you. We're going from B to A, and you want to do horizontal first. If you want to do horizontal first from B to A reach, you can't do it this way because you would be doing your vertical first. You see what I'm saying? It would have to go from here. You follow me? So you always want to do your horizontal first on these when you're making these triangles, and the only way I can go horizontal is going this way, and then go vertically. Now listen to me on this. And the reason I want to do this is because it's going to help us in the end. On these, it matters if you give me negative or positive numbers. It usually don't, but in this case, when we partition, then it does. So for this, since we're going from B to A, we went from B back to A. Our horizontal count, is that going to be negative or positive? Negative, because we're going to the left, right? How many did we go to the left? Negative what? Negative 9. And then from B to A, did we go up or down? That's negative 2. Negative what? So negative 3. So those are my counts on this one. Negative 9 and negative 3. Alright, after I get those, I'm going to write them up here. Horizontal count was negative 9. My vertical count was negative 3. And then we're dividing by the number of segments, which was 3. So my horizontal movement would be negative 9 divided by 3, which is negative 3. My vertical movement, negative 1. So this is telling me how to move horizontally and vertical on this partition. It's telling me to move negative 3 units and then down negative 1 each time. And since my ratio is 1 to 2, I only got to do it once. I'm going to do all 3 just to get the points. But after I do that 1, that's when my partition is going to be at. But it's from B to A though. So we're going from B back to A. So from here, negative 3. 1, 2, 3. Down 1. That's my first point. That will actually be P. But I'm going to go ahead and do the other one so I can see all of them on here. And then down negative 3, down 1 here. Yeah, because it's split 1 to 2. If it was 2 to 1, then we would go to this other one. You feel me? But if it's 1 to 2, so we're going to the first one that we do. Alright, so my partition point will be here because this is 1 to 2 going from B to A. And then you just need to tell me that point. P is at, what's that point? I put you in a good space to win. I want to see you do number 3 and 4. I'll come around. Shouldn't take you long. It didn't take them long in them classes. Just make sure you graph right. A lot of people messing up graphing number 3 for some reason. They got that -4, -3 one. Confused. They had it in the wrong spot. I don't know why. So your first one is 1 to 3. The second one is 3 to 1. I think they both going from A, B though. Alright, so we're looking at the practice for partition in the line segment. Given, oh yeah, a couple things. We wrote questions differently on here just so you can see, be exposed to different kind of questions, all asking you to do the same thing. We just know from experience when y'all get on the test, if a question is written a little bit differently, y'all start freaking out. All these questions are actually pretty much the same thing. We just kind of wrote them all differently. Given the points A and B, find the coordinates of point P on the directed line segment AB that partitions AB in a ratio of 1 to 3. Plot P along with segment AB. My bad. Can't speak. -1, 2. B is at 7, 8. How many segments you got, Chris? Thank you. 4 segments. And then on this one, we're going from A to B. So I'm doing my horizontal from A first. And we down here. Then I'm going up to B. So from A to B horizontally, I'm moving positive how many spaces?
8.
Positive 8. And then I'm moving up, so that's positive how many? 6. So positive 8 and positive 6. I'm going to do these out to the side. That's why I got space set. H, my horizontal is 8. My vertical is 6. Like Chris say, our parts are 4. So divided by 4, divided by 4. 8 divided by 4. And then 6 divided by 4.
And then like there's gonna be 2 points on. No, 1 point on. Over 6 1 time.
Is it 1.5?
It is 1.5.
I thought he was guessing.
The 4, you get 1, and then you got 2 left over. 2 over 4. Y'all tripping. Y'all bad at math. Alright. So these are my walks. I'm showing you this one obviously because you got a decimal on this one. But 0.5s aren't hard to handle, so you can still kind of count with this one. It's the one on the back that you probably ain't going to be able to count. You're going to have to calculate it. And I'm going to show you that one again probably tomorrow too, but I'm going to show it to you right now. Can I wait? It's too loud. Can I wait? Just let it wait. Alright. So we're going from A to B. We're splitting 1 to 3. So after we get that 1, we're really going to be at P, but I'm going to do all my splits anyway. So you're moving over from A to B, 2 horizontally to the right, 1, 2. Then you're going up 1.5. 1.5 lands you right here on this point. And then you do it again from that point over 1, 2. Then up 1.5 will land you here. And then you do it again over 1, 2. Up 1.5 will land you here. And then if you was to do it one more time, you would land on point B. But these are my partitions.
3.5.
Huh?
You do 1, 3.5.
Exactly. So once you get there, it should be kind of obvious to you where your point is. And Reese told us just now. He said 1, 3.5. That's my partition point here. Because we're doing 1 to 3. Alright. Questions on that one? Now, if you had a hard time seeing your point fives, you could calculate on this one. They only asked me to move over 1 for my partition, 1 to 3. So for the calculation, let me show you what you could have done. I know I'm starting at A. That's my starting point. So if I wanted to calculate this, I would write down my starting point as A, whichever that point was, which was -1, 2. And then that starting point, I would just add my change in X and my change in Y to that. My change in X is my horizontal change. It's a +2. So to -1, I would just do +2. And then my vertical change is +1.5. So that's +1.5. If I wanted to do that math, I could, and I would get the same coordinate. And then that would tell me my partition point P, because I'm only moving over 1. So I only got to do the addition in one time. -1 plus 2 is 1. 2 plus 1.5 is 3.5. You could do it that way too if you wanted. If you had trouble counting it off the graph. Like for the next problem, we're going to have to do it that way because the decimals are going to be too wild. It ain't going to be 0.5. Alright, we good? Number 8. Let's look at that. Find the coordinates of point P so that P partitions A and B into a ratio of 1 to 3. A is at -2, 4. B is at -7, -7, +5. Sorry. So graphing these points, -2, -4. That's my A. Oh yeah. B is -7. Not that one. You ain't doing the right one. Number 8, girl. Number 7. +5. Sorry. So here, it's point B. Now on this one, it told us to still go A to B for our partition. Only thing is, to go from A to B on this one horizontally, I would have to move back to the left. So you need to understand that it's not a positive movement, but a negative movement. Not bad. And then I gotta go up. So this is my triangle from A to B. And I did skip a step. I didn't get my segments. Chris, how many segments, bro? Thank you. Alright. Horizontally from A to B. What is that? Who? -5. Thank you. So -5, that is your walk horizontally from A to B. Vertically, +9, right? Alright, so those are my two numbers, 9 and -5. Then from there, like I said, Chris said we have 4 segments because the ratio is 1 to 3. So down here, horizontally, I'm going to have 9. Vertically, I'm going to have -5. Both of them are being divided by 4. 9 divided by 4. Anybody know that? I know it. Oh, why y'all ain't stopping me? I'm messing this up. I'm really tweaking. I know.
Mr. Bronson.
I'm messing this. Oh yeah, this was a test and y'all failed. I bet. I'm writing in pen, so I can't. I gotta change. This is my vertical, bro. I'm about to screw the whole thing up. This is my horizontal. My bad. I'm about to say I ain't think that number came first. Sorry, y'all. If you can switch it around, I suggest switching it around. I like my H to go first. My bad, yeah. I wrote in pen though, so I'm stuck. That's why we don't write in pen. Alright, so let's do the horizontal first, the one that's supposed to go first. -5 divided by 4. Nobody got no calculator? Yeah, 1.25.
And then is it Z like 2 points?
Why don't have no calculators?
Chris, use your calculator. Use your calculator.
I know what it's going to be. I mean, I guess I can just not have to wait in. 2.25. So my horizontal change is -1.25 and vertical is 2.25. And on this one, this is what I was talking about. Y'all gonna have a hard time trying to get on the graph and count back -1.25 and then count up 2.25. That's gonna be hard for y'all to do, hard for y'all to see too. So for these, when the decimals get like this, I would suggest you do the math on it. The math is going from, so it's telling us to go from A to B. Point A, that's where we're going to start our partition from. And we got to go 1 to 3. So we really only got to do it once, because we're stepping over, by the time we step over 1, we'll be in the right partition point. But we're going from A. A, they say, was at -2, -4. And then from there, we're going to do this math. The math is horizontally, we went -1.25. So we're going to put that under our X. That's our change in X. Our change in Y vertically is plus 2.25. We need to do that math on these coordinates, and that'll give us our partition point. And so tell me what point P is. Exactly. Yeah, -3.25, thank you, sir. Comma. Go ahead. What? What you said? -1.75. Hopefully it's gonna correct yourself. -1.75.
Definitely is a 2.
Yeah. That's all good. So honestly, that's our answer right there. We just put it up here in the box. -3.25, comma, -1.75. Now we could try to graph that if we wanted to. Be a little hard though. So, and graphing it, this point, you're going from 0, 0, because this is the actual point where the partitioning is. So from 0, 0 to try to graph that partition point, you go back -3, then 0.25, quarter over the way over, and then you would go down a full 1, and then 0.75. It'll be about right there. It's probably somewhere up in there. Like I said, that's hard to try to count that if you're just using the numbers. You would just be better adding to your point A and just finding that coordinate. Because y'all made me do that problem.